All right, so in the last video, we were talking about doing a specific example where we did it two different ways. I'm going to show you another example where, in this case, one method is definitely going to be easier than the other method. And so in this example, we're going to find the area between the two functions y equals x minus 1 and y squared minus 2x plus 6. Now, I'm going to make sure I mention that I'm using the function, that word function, very, very loosely in this case, and you're going to see why in just a second. So, for instance, I'm going to go ahead and do the first one, which is y equals x minus 1. That's a straight line. It's not going to be that hard to graph. I'm going to go ahead and graph it in blue. And so here I go. So y equals x minus 1 has a y-intercept of negative 1. It has a slope of 1, so it's just going to go up 1 and over 1, up 1 and over 1, up 1 and over 1. So if you notice, we're getting kind of these nice numbers. It's also going to go down 1 and left 1, down 1 and left 1, down 1 and left 1. And you notice I kind of made my graph a little bit on the bigger side. And you're going to see why in just a second. I'm going to try to connect these using a line as best as possible. So there's my line. Again, that's y equals x minus 1. Now, the trick on this other one is y squared. Y squared equals 2x plus 6. Now, that y squared is going to throw me for a loop, and here's the reason why. Anytime you see an x squared or a y squared, it's a parabola. But normally, if it's an x squared, it's either going up or going down. Since this is a y squared, it's not going to go up or down. It's going to go left or right. So here's what I'm going to do. Instead of trying to plug in x values to see what numbers I get, I'm going to plug in y values and see what I get. And I'm going to rearrange the function so it makes it a little bit easier. Here's what I'm going to do. So I'm going to take that y squared equals 2x plus 6, and I'm going to just solve for x. So I'm going to take y squared minus 6 equals 2x. Then I'm going to divide by the 2. So I get 1/2 of y squared minus 3 equals x. So like I said, I'm going to plug in y values so I get nice pretty x's. So here we go. I'm going to plug in, let's see, I'm going to plug in things like negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and 5. These are my y values I'm plugging in to find x. So let's just start off with the easy one. Let's plug in 0. If I do 1/2 of 0 squared minus 3, I get negative 3, okay? So that's going to be at negative 3 comma 0. So that's 1 point. Let me just plug in 1. 1 squared is 1. Half of that is 1/2. Minus 3 makes negative 2.5. But notice, the same thing happens if you plug in negative 1. Negative 1 squared is 1. Half of 1 is 1/2. Minus 3 makes negative 2.5. So notice, this is not actually a function. That's why I said it was I was using that word loosely. It's not actually a function. You have two x values that repeat. And you're going to see that a couple more places. Let me keep going. So I'm going to plug in 2. 2 squared is 4. Half of 4 is 2. Minus 3 makes negative 1. You're going to get that both for negative 2 and positive 2. I'll plug in 3 and see what happens. If I plug in 3, we get, let's see. 3 squared is 9. Half of 9 is 4.5. Minus 3 makes 1.5. Plug in 4, you get 4 squared, which is 16. Half of 16 is 8. 8 minus 3 is 5. I'm not going to worry about that 5 down on the end because if you notice, I'm already run out of x values here on my graph. So let me go ahead and just start graphing these. So I've got 5 comma 4, which, look, there's an intersection. That's that one. Then I've got 1.5 comma 3, which is here. I've got negative 1 at 2. I've got negative 2.5 at 1. I've got negative 3 at 0. Or excuse me, I put that in the wrong place. Negative 2.5 at 1. There we go. That makes more sense. And then negative 2.5 at negative 1. Negative 1 at negative 2. There's the other intersection. And I'll go ahead and do this last one. 1.5 at negative 3. Just so you guys can see my parabola. In this case, is opening up to the right. Now, here's the trick here. If I were to try to integrate using x's, notice my rectangles on most of them are red on top, blue on bottom. However, you get to this area over here where it's red on top and red on bottom. And that is not going to work for integrating x's. It's just not. We cannot do that. It's not going to come out nicely. So in this case, it's going to be much easier it's going to make my life so much nicer if instead of using x's to integrate, I'm going to turn everything into y's and integrate this way. I'm going to make my rectangles go left to right instead of up and down. Now, that means I've got to write it in terms of y. Well, look at Mr. Harold. Already one step ahead. He already switched one of them to y's anyways. So, I just need to switch the other one to y's. So, I'm going to make that in terms of y. Easy way to do it. Y equals x minus 1. Just add 1. Y plus 1 equals x. Boom. There's the other one. So, those are the two functions of y that I'm going to plug in. Now, that's why I said I was going to use the word function loosely, is it's not a function in terms of x, but it is a function in terms of y. So, here I go. I'm going to erase this table. I'm going to leave my graph. It was very helpful. I'm glad I did it, because now I know what y values I'm going to use. So let me repeat one more time. I'm going to integrate. In this case, the blue line is first. It's the one farther to the right. So I'm going to integrate with y plus 1 first and subtract the 1/2 of y squared minus 3. I'm using in terms of y. So now the question you're going to ask me is, hey, Mr. Harold, what are my bounds of integration? Well, if I look at the y values, this y value where they intersect is -2. This y value where they intersect is +4. So that's the bounds, -2 to 4. Okay, so now all I got to do is integrate. But I could even combine some of these like terms ahead of time. So distribute the negative and add. So let me go ahead and do that real fast. -2 to 4 of y plus 1 minus 1/2 of y squared plus 3 dy. And 1 plus 3 makes 4. And I'm going to go ahead and rearrange it a little bit easier. So -1/2 of y squared plus y plus 4 dy. And we integrate. We integrate. So -1/2 of y squared is going to become y cubed of -1/6. That's going to become plus 1/2 of y squared. And that's going to become a 4y. We are still evaluating from -2 to +4. So I'm ready to plug all that stuff in and get my answer. So -1/6 of 4 cubed plus 1/2 of 4 squared plus 4 times 4. All of that is going to be subtracted by essentially the same kind of thing. -1/6 times -2 cubed plus 1/2 of -2 squared plus 4 times -2. And I'm going to switch over to my handy dandy calculator and go ahead and let it do the work. So -1/6 times 4 cubed plus 1/2 of 4 squared plus 4 times 4. I'm going to go ahead and say that's 40/3, just so I don't have to do so much typing. I'm going to go ahead and switch those 4's out for -2's. Shouldn't take me but 2 seconds. Let's see. All right, that gave me minus -14/3. So if I add, because that's what's happening with these double negatives, you're going to get 54/3. I wonder if that simplifies. What do you guys think? 54/3? Oh, boom, 18. And there is my magical little answer at the end. So again, notice very carefully here. Sometimes it is easier to use y variables instead of x variables. So that's the important thing you want to remember here. And again, graph it, graph it, graph it, graph it, graph it.